Mr. Tarrou. In this video, we're going to work through three multi-part examples. To really kind of argue it's more than three examples, but at any rate, looking at angles that are created when two lines are intersecting a circle. Now, we can have that intersection in the middle of the circle or inside the circle, not in the middle, that'd be the center, doesn't have to be the center. Or we can have that intersection point outside the circle. So, the measure of an angle, here angle A, is the measure of the angle formed by two lines that intersect inside a circle is half the measure of the sum, probably should have added that, of the sum of the intercepted arcs. So we're going to say, okay, we have two lines intersecting the circle, the intersection point is inside. You can kind of think of these, remember, well, I can't really call them chords because a chord is a segment whose endpoints are on the circle, but these lines are intersecting the circle twice, so if I were to just sort of erase the portion that was extending beyond the circle, they'd be chords. So you could think of, okay, I have an intersection of two chords, if you will, and this angle is the sum, the average of the sum of these two arcs. Now we're measuring these arcs in degrees, not in length, so here we go. The measure of angle A is equal to 1/2 the sum of those two arcs created or between those two lines intersecting inside the circle. Well, what happens when the intersection of these lines are outside the circle? I can see these colors. Hopefully you can see them in the camera. I have two yellow lines, both of them intersecting the circle twice, and the intersection point is on the outside. I could kind of call these chords again, but they're not segments. They're actual line, they're complete lines. So, and they extend actually, on through this intersection. I just wanted to make a neater picture. I've got some, I have an orange angle, if you can see that. It's consisted of a line intersecting the circle twice and a line intersecting the circle only one time, which means that this orange line, and it's also bluish purple, if you can see that, maybe you can't see that, but this is a tangent line touching the circle only once. Or we have an intersection of two lines that each of those lines are a tangent line. And either way, the intersection point of those two lines are the outside of the circle. If that's the case, and there's three cases up here if you will, we have the measure of angle A is equal to 1/2, now not the sum of these arcs, but the difference. Now, my textbook shows this with parentheses, 1/2 the difference of arc X minus Y. Your book might have some absolute value symbols here, because you can't have a negative measurement. And if your textbook uses absolute value symbols, that simply means that if you happen to accidentally do the small arc minus the larger one and get a negative difference, the absolute values will take care of that and make it positive, making sure that you end up with a positive measure for angle A. Okay, so I guess I'm just going to read now what I've verbally said. The measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. Okay, so let's get to these three examples and kind of see how all this works out. Hey, before we start our first example, I normally have my external microphone and my camera set on mono to try and help. I'm afraid it might sound too echoey in this room that's relatively small as I shoot these videos. And I started the video off and accidentally with my microphone on stereo. So I don't normally, I've never asked if there was a preference. If you noticed a sound difference, sound change, and you liked the first part better than the second part, or you liked the mono better than the stereo, which I think I like better, let me know. Okay, at any rate, our first example. If the measure of angle, now I'm going to do two examples off this one circle, that's why I'm defining these variables here. If the measure of arc AB is equal to 38 degrees, and the measure of arc CD is 74, certainly not drawn to scale, what is the measure of angle COD? You should never trust the scale of a diagram anyway. Well, this is this is the first example, so it's going to be the most straightforward. I have to, well, I didn't draw the lines this time. I actually just drew the chords, the section or part of the lines that are intersecting inside of the circle. And I want to find the measure of that angle between these intercepted arcs. Okay, well, I just said in the previous screen there was sometimes we took half of the sum and sometimes we took half of the difference, and maybe I've already forgotten. Well, this is a bit of a stretch, but these two lines are intersecting inside the circle and it kind of looks like a squashed plus sign. Maybe that'll be a reminder for you to add those, the measure of these arcs before you divide by 2 to find the measure of that angle. So we're going to add. So the measure of angle COD, that's not cash on delivery, is going to be equal to, well actually it is, but we're not taking delivery, we're doing some math, is equal to the average, or half. I keep saying average because I'm adding 2 numbers and I'm dividing by 2. That would be finding the average. If I were adding 3 numbers and dividing by 3, that'd be the average as well. If I was adding 3 numbers and dividing by 2, I'd just be taking half the sum. So we're going to take half that sum, 38 plus 74. Well, let's see here. That's going to be 1/2. 70 plus 30 is 100. Now we're at 108, and now we're at 112. And half of 112, well, let's see here. 11 divided by 2 is 5, but 5 times 2 is 10. That leaves a remainder of 1. So I got 12 left over, and half of 12 is equal to 56 degrees. So the measure of angle COD with our first example is equal to 56 degrees. Okay, now I'm going to erase these numbers because this second example here, part B, I want to use the same diagram, but I didn't, well, I was just too lazy to make another one. So I'm going to erase those numbers. I'm going to start over like it's a brand new problem. The measure of angle AOB is equal to 46. Now, we just said that COD was 56, and vertical angles are on opposite sides of an intersection of 2 lines. So if I was extending the same question, angle AOB would be 56 degrees. So remember, we're starting a brand new problem. Probably should have said this example 2 instead of just part B. So the measure of angle AOB is equal to 46 degrees. We have the measure of arc AB is equal to 10. So that would have to be 10 degrees. If I just leave it without the degree mark, you might think it's a length. And I want to find the measure of arc CD. Okay, well, I still have an intersection of 2 lines or chords inside of our circle, so we're still going to say that the measure of this angle, the measure of angle AOB, is 1/2 the sum of the 2 arcs. It's going to be 1/2 the sum of arc AB and CD. Okay, so I'm writing this out here because, you know, this second question is a little bit different. The first one was very straightforward. I gave you the 2 arcs and I asked for the angle. So we just simply add those 2 arcs divided by 2. Boom, there's our answer. Well, now this one gives us the angle where these 2 lines are intersecting, and it's asking for the measure or the degree of one of the arcs. Well, if you have any doubt of how to solve a problem, the formula tells you what to do. It tells you what it needs and where it belongs. If you just plug those numbers in where they belong, and hopefully with your algebra skills, you'll know how to finish the problem. So I'm writing the formula out, and we're told that angle AOB is 46, so I'm going to take this out and put in a 46. The measure of arc AB is 10 degrees, so we're going to take that out and put in 10 degrees. And, okay, well, I'm looking for the measure of arc CD. Well, how am I going to figure it out? Well, one way of doing this is to take the 1/2 and distribute it through the parentheses, which I think I'm going to do. What you could also do is recognize that this entire parentheses is being locked together with the parentheses, and this one thing is being multiplied by 1/2. So you could multiply both sides by 2 to undo that division of 2. So either way, it's going to be relatively the same number of steps. I'm going to go ahead and take the 1/2 and distribute it through the parentheses. So we have 46, 1/2 of 10 is equal to 5, and then we get plus 1/2 of the measure of arc CD. We're going to start solving this equation. That means we need to add or subtract away from the variable first. So we're going to subtract both sides by 5. And apparently start to run out of room. We got 41 is equal to 1/2 the measure of CD, the measure of arc CD. Okay, we'll have enough room to finish this. Again, I have that multiplication, or excuse me, I have a fraction. Now, fractions represent division, so we can get rid of this fraction in two ways. Now, with the numerator being 1, either way is going to seem like they're equally equal number of steps, but if you have fractions and you have trouble with them, you can get rid of them in 2 steps. You can undo that division of 2 by multiplying by 2, which is what it's going to seem like I'm doing. But if this numerator was something other than 1, and I just multiplied both sides by the denominator, which I could, I would still have to get rid of that numerator. Like if this were 3 over 2, and I multiplied both sides by 2, I would have 82 is equal to 3 times the measure of CD, and I'd have to then divide both sides by 3. Or, if you're more comfortable with fractions, and again, this has a numerator of 1, so it's not going to seem like it's any different, but if you have a fraction, you can get rid of it in 1 step instead of 2 by multiplying both sides by the reciprocal. So I'm going to take the 1 over 2 and flip it, and multiply both sides by 2 over 1. And when I do that, that multiplication of 2, or that multiplication of 2 over 1 is going to cancel out with that fraction of 1/2, just leaving me with 2 times 41 is equal to 82, and that is equal to the measure of arc CD. And let me just check my own work. Excellent. Okay, over here, now we have a couple of lines that are sort of intersecting the circle, but intersecting themselves outside the circle. So that means that to find the first question here, now this is a 2-part question, but I don't have, if something something equals this, solve for this, and if something something equals this. So these 2 parts are coming off the same diagram, and I already have the numbers labeled in there. So the measure of angle X, well, it's created by 2 lines that are involving the circle. Now these 2 lines both happen to be tangent lines, but that doesn't matter. They're involving the circle and they're intersecting outside the circle. So the measure of angle X is going to be equal to the difference of the 2 arcs. So the measure of angle X is going to be 1/2 the difference of the 2 arcs. Now I want to take the big minus the small, so I don't have to worry about absolute values. Okay, so the intersection points are right here, the tangency points, and that means I have an arc AD, which has the measure of 100 degrees, and then I have the measure of an arc that goes more than halfway around the circle. So I can call this arc AFD or AED, and of course I can go in the opposite direction, but the point is, I need to know what the measure of this entire arc is. Well, that's simple. A full rotation around a circle, I don't know why I just made my hand go around twice, but a full rotation of a circle is 360 degrees. And these 2 tangency points, if I'm only concerned about these 2 points around the circle, then I've only got 2 arcs. I've got one arc that's 100 degrees, and I have another arc. I mean, it's broken up into 3 parts, but I want to measure the whole thing. I have another arc that has to add up with 100 to make 360, and of course that's 260. So we have the measure of angle X is equal to 1/2 260 minus 100. That's going to be equal to 1/2 of 160, which is equal to 80 degrees. So the measure of angle X is equal to 80. Now, this one's going to take us having to find some information now it's related to this answer, but it's not the answer. I want to find the measure of arc FE. Well, let's get some orange. So I want to find the measure of this arc. Well, this arc is created by these 2 lines or chords, since they don't go on forever, they're ending on the circle. But these 2 chords are intersecting inside the circle. Okay, so the measure of arc FE. Well, on the other side of these lines that are intersecting, I have, again, arc AD. If I don't figure out, based on other information in the diagram, some more information with these 2 arcs, I'm not going to be able to find this answer. So, because I need to know something about angle C, or one of these two angles, or vertical angles, are going to be equal, FCE or ACD, to be able to find the measure of arc FE. Well, that's right here. This is 60 degrees. Now, that's not going to be used in any formula involving or working towards directly finding the measure of angle of arc FE. I need to know this angle. Now, you see these two angles here, right? We have angle ACF and FCE. These are adjacent angles forming a straight line, which means they're a linear pair, which means they add up to 180 degrees, or in other words, we call that supplementary. So what angle plus 60 is equal to 180? Well, of course, that's 120 degrees. Okay, so what we have here is the measure of angle ACD, or FCE, which is 120, is equal to 1/2 the difference of the two arcs that are, or excuse me, not the difference, it's inside the circle. Look, plus sign, kind of swished over, but the sum. That 120 is going to be equal to 1/2 the sum of these two arcs. So we have 1/2 times 1/2 of the sum of the measure of arc FE plus 100 degrees. We're going to, I think this time I'm going to immediately multiply both sides by the reciprocal 1/2 just to show you another way of showing the work. We're going to pick up some yellow chalk, I guess. Multiply both sides by 2. That's going to give us 2 times 120 is 240. Equals the measure of arc FE plus 100. We're going to subtract both sides by 100 and get our answer. The measure of arc FE is equal to 140 degrees. And yet again, we have a diagram that is not drawn to scale. But I did check my work before making the videos, and these notes match my notes, so I'm pretty confident that we're good to go. Don't trust your diagrams. They're very rarely drawn to scale. One more example. Woo! Before I go on to the next screen, I just kind of want you to keep your mind open to, perspective and how things should look. If I go from this point and do my best to draw a diagonal, or excuse me, a diameter through the circle, I'm thinking maybe somewhere around there, you can see that this original arc that I marked off as being 100 degrees, well, if this is the diameter, 100 degrees would be just a little bit more than 90. So basically, if I wanted to redraw this and make it, really very good drawing to scale, I would have to take this intersection point out here from the circle and push it much, much closer to the circle to maybe have a diagram that looks something more like this with my tangent lines intersecting at B. Just wanted to bring that up. Now, last picture. Our last example has 4 parts. Okay. I don't care which one of these you find first, or that we find first. Fiend, find, foe, fum. I don't know. Let's do one. Okay. Now, we have to know that this segment here of AE is a diameter. Otherwise, we won't be able to know it. We won't know enough information to be able to finish this problem. Any ideas? How about we find the measure of arc BC first? Because this is a diameter, and that means that on each side of this diameter we have a semicircle. So this arc of AE and this arc of AE, or ABE and AGE, they have to be 180 degrees. And this 180 degrees is made up of 3 parts. One part is 50, one part is 70, and there's only one part left. So it has to, the measure of arc BC has to make all 3 add up to 180. So the 180 degrees is going to be equal to 50 plus 70 plus the measure of arc BC. So we're going to take these two and add them together and get 180 is equal to 120 plus the measure of arc BC. Subtract both sides by 120. That's two examples. I put my variable on the right-hand side. I don't exactly know why I keep doing that. But of course, that's probably good for you because a lot of textbooks put the variables on the left-hand side and you get used to just moving all the numbers over to the right. When you solve them for an equation, of course, you just want to move the known values away from the variable. And if the variable's on the right, everything goes to the left. Anyway, that's equal to 60 degrees. And that is the measure of arc BC. So I'm going to go ahead and take this 3 out and just put in here our answer of 60 degrees. Okay, let's go ahead and find the measure of arc GE. Now, arc GE is created by a couple of lines intersecting the circle. Now, there's a line intersecting the circle in 2 places, and then we have a line intersecting the circle at only 1 place. So this would be a sort of like an extended chord and a tangent line. And the measure of this angle formed outside the circle is equal to 1/2 the difference, 1/2 the difference of the 2 arcs which it creates. So the measure of angle F, which is equal to 48 degrees, is going to be equal to 1/2 these. Now let's put the larger arc first again so we don't have to worry about negative measurements. And we've got, let's see here, we've got this arc of GE and the other arc that's inside this angle. It's kind of like tempting to let's sort of look at this quickly and just go all the way around the circle, but the other arc that's created by this angle is on this other side, which is right here. Now that arc is 180 degrees. You don't include this arc AG because it's outside the angle of these two, or outside these 2 lines that are helping to make this angle. So 48 degrees is equal to 1/2 the difference of 180 degrees again. That's why we needed to know that was the diameter, AE. So 180 minus, well, that's what we're looking for, the measure of arc GE. Some say they bring good things to life. We're going to, oh look, my variable's on the right-hand side again. We're going to multiply both sides by 2 to undo this division of 2, or this multiplication of 1/2. So, and we're going to go ahead and multiply both sides by 2. We're going to get 96 is equal to 180 minus the measure of arc GE. We're going to subtract both sides by 180. Now, it might be getting concerned because we're looking for a measure of an arc, and this measure right now is coming out to be negative, but we have a negative here that we're going to divide to both sides to take care of that. Okay, 96 minus 180. Well, let's do this in reverse and just know the difference is going to be negative because 180, the larger number is negative. 180 minus 90 is 80, and then 80 minus 6 is 74. And it'll be negative 74. Then we're going to divide both sides by -1 to get it away from the variable that we're looking for. And we get 74 degrees is equal to the measure of arc GE. So 1 is equal to 74. Okay, let me just make sure that that is what I got in my notes as well. 180 minus 90, what was that again? I said that was 80, but 180 minus 90 is 90. Minus 4 is 84. Some of you are probably already commenting, hey, you can't subtract, it's supposed to be 84, not 74. I caught it. Okay, that's why it's always good. I'm talking and trying to do math at the same time, and that doesn't always work. Make sure that when you're doing your homework, you're staying focused on it as well. Okay, so let's find the measure of arc AG. Well, now that we know that this arc GE is 84 degrees, and again, not drawn to scale, and again, this is a diameter AE, so that means that these two parts also have to add up to 180 degrees. So the measure of arc AG is 180 minus 84. Let's try and do this right this time. 180 minus 80 is 100, and 100 minus 4 is 96. Okay. Let me just check one more time. AG, yes, 96. Well, the only thing left is the measure of angle 4, or the measure of angle ADE. Okay, well now angle 4 is an intersection of two lines inside the circle, and sort of look at this as a sort of warped plus sign. Remember, the measure of an angle formed by two lines intersecting inside a circle is 1/2 the sum of the two arcs, not the difference. So the measure of angle ADE, or you could say BDC, is equal to 1/2. Okay, what arcs do these intersections make? There's an arc over here of, you can see the green. There's an arc here of 60 degrees, and there's another arc here. Oh, okay, it's ending at the diameter, so we have that big arc of 180 degrees again. So 1/2, 60 plus 180, that's going to be, oh look, my variable's on the left finally for a change. That's going to be equal to 1/2 of 180 plus 60 is going to be equal to 240. And 1/2 of 240 is 120 degrees. So, I'm Mr. True. Time for you to go do your homework.